In 1977, NASA launched two spacecraft into the unknown, aiming to explore the far reaches of our solar system and beyond. One of them, Voyager 2, has become an icon of human curiosity and ambition. Decades after its launch, the spacecraft is still sending back data, and what it's uncovered at the edge of our solar system is something few are talking about, but everyone should be. Voyager 2 is the only spacecraft to have visited all four gas giants: Jupiter, Saturn, Uranus, and Neptune. But what's truly remarkable is its journey beyond those planets, into the outermost layers of the heliosphere, the giant bubble created by the sun's solar wind that envelops our entire solar system. The boundary where this bubble ends and interstellar space begins is called the heliopause. And when Voyager 2 crossed that boundary in November 2018, it confirmed something that had only been theorized before, and it shocked scientists around the world. As Voyager 2 exited the heliosphere, it began sending back data about a region of space where the influence of the sun dramatically weakens and the interstellar medium begins to dominate. But what the spacecraft detected there wasn't just the absence of solar wind. Instead, it revealed a surprisingly dynamic and structured region, filled with magnetic anomalies, dense plasma waves, and evidence of cosmic rays behaving in ways no one had quite expected. These aren't just dry scientific details. They're clues that challenge our understanding of where our solar system truly ends and what lies beyond. One of the first unexpected findings was the sudden drop in solar wind particles and a corresponding increase in high-energy particles from outside the solar system. This wasn't surprising by itself, but what baffled scientists was the sharpness of the transition. The heliopause they had thought would be a gradual shift, a kind of cosmic gray area. Instead, Voyager 2 recorded it as a sharp, well-defined boundary, almost like passing through a wall. This suggested that the heliosphere may be more like a shield or membrane, with unexpected strength and rigidity, rather than a fading boundary. Adding to the mystery, Voyager 2 measured interstellar plasma that was far denser than anyone predicted. Interstellar space, we're often told, is a near vacuum. But just beyond the heliopause, Voyager 2 found that the density of this plasma was over 40 times greater than what it had encountered inside the heliosphere. This implies that the interstellar medium is not as empty as once thought, and raises questions about how this material interacts with our sun's outermost influence. Even more fascinating was the magnetic field. Before the crossing, Voyager 2's instruments detected magnetic fields carried by the solar wind. After the transition, the magnetic field shifted direction, but didn't become as chaotic as models had predicted. Instead, it became more ordered. This unexpected order suggests that the interstellar magnetic field might be exerting a much stronger influence on the heliosphere's structure than we imagined. It also supports the idea that our solar system doesn't simply drift aimlessly through space. It's embedded in a highly active galactic environment. But there's something else that Voyager 2 revealed, something that hasn't gotten the attention it deserves. It detected plasma oscillations, natural vibrations in the density of interstellar plasma, that offered a rare opportunity to directly measure the density of this strange new environment. This kind of data hadn't been available since Voyager 1 made a similar crossing years earlier, but the difference this time was that Voyager 2's instruments were still fully functional, giving us much clearer and more detailed readings. And those readings are reshaping our picture of the cosmos. There's also the mystery of cosmic rays. These high-energy particles constantly bombard Earth, but their origins and behavior are still not fully understood. As Voyager 2 moved into interstellar space, it began to measure how these rays penetrate the heliosphere and interact with the solar wind. What it found is that our solar system's protective bubble does a surprisingly effective job shielding us from the harshest cosmic radiation. Without the heliosphere, life on Earth might be bombarded by lethal radiation, suggesting that this invisible bubble could be critical for life to exist at all. Yet, despite all this groundbreaking information, the general public remains largely unaware. These findings don't often make headlines. The edge of the solar system sounds distant and irrelevant to daily life, but the truth is it holds answers to some of the biggest questions we've ever asked. How does our solar system interact with the galaxy? What conditions protect life? Are there other systems like ours with similar protective bubbles? Voyager 2 is giving us a front-row seat to explore those questions. The spacecraft is now more than 12 billion miles from Earth and still communicating with us. Every signal takes over 18 hours to arrive, traveling at the speed of light. It's a tiny whisper from the edge of the solar system. A whisper telling us that there's more complexity and beauty at that boundary than we ever imagined. It reminds us that space is not a static void, but a place of constant change, shaped by forces both seen and unseen. What's more, Voyager 2's journey is far from over. Although its power is fading and its instruments are slowly shutting down, it's still drifting deeper into interstellar space. The data it continues to collect is invaluable. It's a legacy mission, one that will be studied for generations, offering insights not just into our solar system but into how star systems like ours are formed, evolve, and exist in the wider galaxy. And then there's the philosophical aspect of it all. Voyager 2 isn't just a machine, it's a symbol of our desire to reach beyond the known, to understand where we come from, what surrounds us, and ultimately, where we might go. Its golden record, a time capsule carrying the sounds, images, and messages of Earth, is hurtling into the galaxy, potentially to be discovered by another form of life. It's a cosmic message in a bottle, a sign that someone here wanted to connect. Voyager 2's findings at the edge of the solar system are rewriting textbooks and redefining what we thought we knew about space. They're showing us that the boundary between our sun's influence and the galaxy beyond is not just a line in the sand, it's an active frontier, filled with surprises and hidden dynamics. And while most people ignore it, preferring more glamorous headlines, the edge of our solar system is turning out to be one of the most exciting places we've ever explored. Voyager 2's journey has opened the door to a new era of space science. The more we learn about the edge of the heliosphere, the more we realize how interconnected everything is. Our sun's magnetic field, the interstellar winds, the charged particles racing through the galaxy, they all form an intricate dance that defines the bubble we live in. And it turns out this boundary isn't just important for academic understanding. It could be essential for understanding how life, planets, and entire star systems survive in the chaos of space. What's truly fascinating is how Voyager 2's data complements the earlier data from Voyager 1. While both spacecraft crossed into interstellar space, they did so in different regions of the heliosphere, allowing scientists to compare the structure of the boundary in different directions. This revealed that the heliosphere is not a perfect sphere, as once believed, but is instead warped and distorted by external forces. Galactic magnetic fields, the motion of the solar system through the galaxy, and even the uneven pressure of interstellar gases all shape the bubble around us in subtle but important ways. This asymmetry means that some parts of the heliosphere might be more vulnerable than others. It could change how cosmic rays enter the solar system or how interstellar material flows in. These variations might seem far removed from Earth, but in reality, they affect the long-term stability of our solar system's protective barrier. And if that barrier were ever significantly compromised, the implications for life on Earth could be profound. Our planet's climate, radiation levels, and atmospheric composition are all influenced, directly or indirectly, by the larger cosmic environment we exist in. Voyager 2 also helps us understand how stars influence their surroundings. Every star creates a similar bubble, called an astrosphere, through the outflow of stellar wind. By studying our own heliosphere, we gain a model that can be applied to other star systems. And if we find another system with a similar structure, it could indicate a potentially habitable environment. That makes Voyager 2 not just a tool for studying our own backyard, but a window into the conditions that might support life elsewhere in the galaxy. As we continue to receive data, scientists are developing more sophisticated models of the heliosphere and interstellar interactions. These models are key to future missions. NASA and other space agencies are already planning probes that could follow in Voyager 2's path, with more advanced sensors and communication systems. These next-generation missions could travel faster, farther, and with greater precision, potentially mapping the true structure of the heliosphere in 3 dimensions, and giving us the clearest picture yet of our place in the cosmos. But Voyager 2 is more than just a machine sending back numbers. It's the last human-made object actively exploring the space between stars. The silence of space doesn't stop it. The unimaginable distance doesn't stop it. Even as its power dwindles, it continues to send back the whispers of the universe. It's a reminder of what human curiosity and ingenuity can accomplish. Every new signal Voyager 2 sends is like a page in a story we're still writing. A story about who we are, where we come from, and how far we're willing to go to find answers. And the best part? We're not done yet. Voyager 2 is expected to keep transmitting until around 2026, possibly longer. That gives us a limited but precious window to gather even more data from the edge of the solar system. What will we discover next? What unexpected twist might still be waiting in the dark? Perhaps the most humbling realization is this: Voyager 2 is now traveling through a region of space that has never been touched by humanity. No probe, no telescope, no theory had ever directly examined this environment until Voyager 2 crossed that invisible threshold. In a sense, we are seeing the interstellar medium, the space between stars, for the first time, not through the lens of imagination, but with real data. And it's not empty, it's not silent, it's alive with radiation, shaped by magnetic forces and brimming with mysteries. Voyager 2 has taught us that the edge of our solar system is not an end, but a beginning. A beginning of a much larger story, one that stretches across the galaxy and perhaps even beyond. So, the next time you look up at the night sky, remember that somewhere out there more than 12 billion miles away, a tiny spacecraft is still drifting through the stars, carrying a message from Earth and uncovering the secrets of the universe. Voyager 2 has confirmed what most have ignored. The boundary of our solar system is not a cold, quiet place. It's a frontier teeming with activity, danger, and possibility. And thanks to this little spacecraft, we're just beginning to understand what that truly means.